The summer of 2020 proved disastrous for thousands of Oregon homeowners and the electric company Pacific Power. The utility did not turn off its power lines in places like the Santiam Canyon as a dry, hot windstorm approached in September of that year. Some of their power lines were hit by branches or trees during the storm and sparked fires, in addition to the ones already burning. The resulting infernos damaged or destroyed 2,500 properties across the state. A lawsuit followed, and a jury recently awarded damages in the tens of millions of dollars for homeowners. But even before the fire and the lawsuit, meteorologist Steve Vanderberg said the company was talking to him about becoming their fire forecaster as they build up their expertise. Now he leads the fire team.
We are. In fact, we're prepared year-round. We're running models 365 days a year. We're doing analysis. We're looking at vegetation conditions. So yeah, we're prepared for fire season.
Vanderberg worked for the National Weather Service for 10 years, then for another electric company in San Diego for 10 years. Now he's in Portland at Pacific Power and spent the last year and a half building a massive database of historical fire information that can be turned into graphics. It holds 30 years of high-resolution weather and vegetation conditions across the entire western United States.
So it took supercomputers crunching round the clock 16 consecutive months to generate all this data. 10 million, what we call 10 million compute hours to generate all of this data. And now we're analyzing it. We're looking at how does that data inform what happens in terms of wildfire risk, in terms of different kinds of impacts on the grid, and we're using that to create products to keep us ahead of the weather.
Is the value of that you can look at one specific place on one date, but also see through history what's happened there?
Exactly. It's about understanding today's weather or tomorrow's weather in the context of the past 30 years.
Unlike Portland General Electric, Pacific Power does not have an array of cameras with artificial intelligence watching for telltale smoke that shows a fire has started. Instead, Vanderberg and his team rely on their databases, along with remote weather stations and workers in the field. They cover a vast territory, Oregon and 5 other states.
It's both a challenge but also an advantage, because when it comes to understanding how do you predict these things, the more data you have to work with, the better results you may get. The more you have to look at, right? So from a analysis standpoint and trying to understand how do all these conditions impact fire danger, it's an advantage to have a large service territory. But obviously forecasting on this scale can be challenging because the weather varies from canyon to canyon and mountain to mountain, and we have a lot of canyons and mountains in our service territory.
Yeah, much less state to state, Oregon to Wyoming or Utah.
Yeah, so 6 states, highly diverse, a lot of different weather and different challenges, but with the models we're running, we have a very high resolution look at those conditions hour by hour across all 6 states.
To get an idea how it all works, Vanderberg took us back to last year.
New tonight, thousands of Pacific Power customers are expected to face a power shutoff on Friday.
Remember this? It was big news September 7th of 2022. Conditions were ripe for trouble.
Still, it's going to be really windy enough that any fires that are out there or that start will get fanned and could exhibit extreme behavior very, very easily.
Vanderberg pulled up a map showing one danger area from back then, Sweet Home. It's southeast of Corvallis. The yellow lines here show the power grid.
Here we are on the night of the 8th. The green indicates light winds. We're pretty much seeing light winds across the area, right? And as we scroll forward in time, you'll notice that we start to see all these reds showing up along the Cascade Crest, and the yellows kind of spilling down the mountains.
Is red bad?
Red is winds over 50 miles per hour, and the yellows is anywhere from 30 to 50, depending on the shade of yellow there.
Okay.
And you can see as we go through the event how those winds shift and change over time. And you can see here, especially on the night of the 9th into the 10th, how those winds really start to try and channel down the west slopes of the Cascades, right? And so that's where we're seeing, where the winds could impact our infrastructure.
And just so people know, this here's Sweet Home here.
Sweet Home.
Millersburg to the left a little.
Albany out here, and then there's Portland Metro. There's Mount Hood over here, and Hood River. And so, yeah, so you can see, okay, well, what does this mean? We know it's going to be windy. There are red flag warnings in effect. What does this mean? Well, these colors here, these yellows and reds, are indicating a heightened or an increased probability of outages. So now we have a map that shows us those power lines that are actually at an increased risk of having power outages from the wind, right? So now we're really able to hone in, okay, well, where is the potential impact here? And so this is looking at kind of a measure of how dry the vegetation is. And you can see it's all red everywhere, right?
Red's bad.
So what we're able to tell from this is, like, when we look at fuel moisture, every place was dry. But where is it that we're going to focus our actions, to target, to mitigate that risk? And it's where we see this overlapping with the outage risk, right?
And that is why Sweet Home's power was cut at 12:40 a.m. on September 9th, 2022. 2,400 people were left in the dark for 28 hours until the electricity flowed again.
Let's do this one.
Here's another tool they use: forecast projections of winds with an overlay of actual wind readings from weather stations.
This is the data we were pulling in at the time from Echo Mountain, which is just east of Lincoln City. And the black line represents the data we were getting from our weather stations every 10 minutes. And then the blue line represents a forecast of those conditions. And you can see we're monitoring that, and now it's in the yellow and it's approaching the red. And this is when we're expecting the potential for those increased impacts to our power lines from those winds. So this is an example of the data that we can pull in real time that gives us a look at, well, is it windier than forecast? Is it less windy? And how does that compare to what's normal for that location?
The graph showed that the forecast of dangerous winds was coming true, and so the power was also shut off for this area in September of 2022.
Based on both the forecast and also what the weather stations were telling us about the conditions at the time.
Vanderberg says the weather team's goal is to have most of the work done well before the storm hits. That allows time for the utility to put workers in place and warn the local community that the power may be shut off. That's why computer models like this are important. It shows how dry the grass is in the West in real time. This, for example, is Madras and Redmond. The weather team also runs fire simulations to see if something started today, what would happen in a specific area.
In this case, I happen to be looking at flame length, and here's a forecast going from Monday the 26th through Wednesday the 28th. And I can step through in time and we can see, how does that change, power line by power line.
There are other models like this one showing the fire potential index. This shows the greater Portland area. The biggest spike by far there, September of 2020, when the disastrous fires tore through the state. It's one more tool the Pacific Power will use this summer when deciding whether to turn off your power before a potential firestorm.
Because all of this data really takes the guesswork out of it. It's really important to know not just what the weather's going to do, but how that's going to impact the power lines. And what does that mean in terms of the probability of something bad happening? That's really important. And this is what these tools do. They don't just tell us what the forecast is and how windy and hot and dry it's going to be, or how dry the vegetation is going to be. It tells us what the potential probability of an outage is, the probability of an ignition occurring, and the potential consequences of that ignition should it become a wildfire.